Hello everyone. Today we are going to discuss the problem Forever Winter from the Codeforces round 871. So the problem statement is like a snowflake graph is generated from two integers x and y both greater than 1 as follows. Start with one central vertex, connect x new vertices to this central vertex and connect y new vertices to each of these x vertices. For example, we have given a graph. So in this input format, we have given a n and m, and denotes the number of vertices, and m denotes the number of edges, and then m lines is denotes a edge between u and v vertex, right? So we have to calculate the value of x and y. So let's understand this. So basically, we have given this graph in question. So yeah, so in this we having a central vertex, and there are x edges from this central vertex. There are total x edges, and there are y edges from all these additional vertices, right? From all these vertices. So there are y edges. So there are y edges from this additional vertex, right? So for example, in the given graph, we having 1, 2, 3, 4, and 5 edges from this from vertex 15, and 3 edges in each of the vertices out from this. So and this having 3, this also having 3, this also having 3, and this also having 3, and this also having 3, right? And this having 5, right? So this having 5 and all other are having 3. So in this case, x equals to 5 and y equals to 3, because there are 5 edges, 5 edges going out from 15, and 3 edges going out from every vertex which is connected to 15, right? So in this case, what can we do? In this question, what can we do? We just calculate the out degrees of every vertex, and then we formulate the solution for this. So let us say for this example, if I going to formulate the out degrees for this, so 15 give me out degree of 5, and 20 give me out degree of 3. Similarly, 6 give me out degree of 3, and 7 give me out degree of 3 as well, and 8 give me out degree of 3 as well, 3 give me out degree of 3 as well. So I having 5 uh, vertices which give me the out degree of 3, right? So and there are 5 vertices which are 5 or 15 which having out degree 5. So from this we can say, uh, if a vertex having out degree x, if a vertex having out degree x, and there are x vertices, if there are x vertices which having out degree of y, then we can say x should be this and y should be this, right? So this is quite simple. We just calculate the out degrees using map or a vector, and then just formulate the answer. But there is an edge case for this problem, in which let's assume we having a graph 1, if having out degree 1, and let us say we having this two having edges 2, 3, 4, and 5, 3, 4, and 5. So so one having a out degree of 1, 2 having a out degree of 4, and 3 having out degree of 1, 4 having out degree of 1, 5 having out degree of 1. So there might be a case in which all the only one vertex having a out degree greater than 4, greater than 1, and all having out degree 1, all the other vertices. So in this case we can just assume any of the node as any one of the node as our central node which having out degree 1. So in this case our x should be 1, and the only value which is greater than 1 is our value y, right? Which value is not y because this as is repeating, so which value minus 1. So in this case 4 minus 1 should be 3. So in this case x should be 1 and y should be 3, right? So I hope this observation or problem should be clear to you all. So let's move to the solution part, the code part of this. So yeah, so let's move to the code of this problem. So this is not showing. So let's move to the code part of this. So yeah, so yeah, so the code of is like we having n vertices and m edges. So we just take input and I take a vector which stores the out degrees of every node. So I just take input u and v and push every every node to its every edge. It contain every edge. U is connected to v and v is also connected to u. So this show me the every so the connections between the graph, and then I take a map which simply stores the size of the every node from 1 to n. So the size store every size stores the number of out degrees of every vertex, right? If the size is greater than none, I just take a counter. This condition is for if I having only one out degree which is greater than one. This covered the case, the edge case which we discussed in the last, this one, which covered this case, this on this one, and in just we have to count. If the count is 1, then I have to just return x as 1 because we can take any leaf node as x, right? And answer minus 1 because there are 1 as which is repeating, so this should be answer minus 1. And if we having size greater than 2, then if the map having size greater than 2 and there are more than one values which having size greater than out degrees greater than 1, then in this case the answer would be the answer a vertex which having x and its neighbor vertex having answer minus 1 as y, right? And in all other cases we just calculate a x which having only one occurrence in the map because the in every case in this case also there is only one vertex which having out degree 5. So there is only one vertex which having out degree 5. So this we are searching for a vertex which having only out degree which having out which out degree does not repeat, right? So in this case we just make x equals to it dot first, and then we check that how is there any vertex which having x time occurrence. Means we have to form a graph. Like in this there are 5 vertices, so in this case 5 vertices having a same out degree, right? So these all 5 vertices having the out degree as 3. So in this case we check if there is any vertex which having the same out degree as the x. So in this case I just push I did make y as it dot first minus 1 and return x and y. So yeah, this should be all about this problem. I hope the problem should be clear to you all. And so press the bell icon and press the subscribe button for more updates.